All right, let's take a look at these problems here. So I got x plus 1 is equal to 4. All right, well, let's take a look. X plus 1 is equal to 4. So automatically, you can probably guess what x would be equal to. If I put 2 as x, 2 plus 1 does not equal to 4. 2 plus 1 is equal to 3, so that doesn't work. 3 plus 1 is in fact equal to 4. Now, I want to show you how to demonstrate that mathematically. So there is a thing called a tape diagram, so like this. So x goes right there, 1 goes right there in like a tape diagram form, in this rectangular form, and this entire thing must equal to 4. So clearly, right, we have x, which is equal to 3, plus 1 is equal to 4. Or we can do 4 minus 1, which is equal to 3, right? So therefore, x is equal to 3. Why? 3 plus 1 is equal to 4, or 4 minus 1 is equal to 3. Or let's go ahead and do the scale here. So let's just say on the left side of the scale, remember we have to keep this balanced. We're going to have x on the left side and the 1 on the left side as well. And on the right side, I have 4. So remember, whatever I do to one side, I also have to do to the other side. So there are several ways I can get rid of this 1. So what I'm going to do is I'm actually going to add a -1 block. I'm going to add a -1 block here too. Okay? If I add a -1 block, 1 plus -1, that equals 0. So what's remaining on the left side? X is remaining on the left side. 4 plus -1, well, that is equal to, that's going to equal to 3. Therefore, I have x is equal to 3. And that's exactly what we had here. X is equal to 3, x is equal to 3. Now, there's another way of doing this. You don't have to necessarily add -1 if you don't want to. You can actually keep it like this, right? So we have x plus 1 is equal to 4, equal to 4. What you can actually do is break up this 4. I'm going to break up this 4 into a 3 and then a 1. Okay, so what can I do? If I remember, whatever I do to one side, I have to do to the other side because I have to keep the scale balanced. If I take away the 1 here, then I must also take the 1 right here, which means that x must equal to what? 3. And so that's another way of doing this problem. Let's just do another one here. So I got x plus 5 is equal to 7. So on the tape diagram, I'm going to put x and 5. And this entire thing is equal to 7. Well, what must x be? Okay, if I try 1 here, 1 plus 5 doesn't equal to 7. 2 plus 5 is in fact equal to 7. So x must equal to 2. Okay, so now I'm going to also show with the scale, we got x plus 5, so that's x and 5. And this is going to be 7. I can add -5 on both sides, so I can add -5 on both sides. And I have to remember, whatever I do to one side, I have to do to the other side. That's going to cancel out, right? That's going to cancel out. What's remaining? X is on the left side. And what is 7 plus -5 together? Well, that's going to be -2. Remember, 7 plus -5. So 7 plus -5, that's 1, 2, 3, 4, 5, 6, 7. And then -5, right? Adding -5. 1, 2, 3, 4, 5, 0 pair, 0 pair, 0 pair, 0 pair, 0 pair. What's remaining? 2. Okay? So it's actually -2. It's actually +2, right? 7 plus -5 is 2. So x is equal to, therefore, 2, right? So x is in fact equal to 2, which what we got right here. Or if you don't like that, you can just rewrite this like this, and you can go like that. And you can go rewrite 7 into 5 and 2. 5 and, I'm going to do 2 and 5. 2 and 5. Now that's exactly balanced. Why? 2 plus 5 is 7, right? So even though I'd switch this around, it's still equal to 7. Left is x plus 5. Now I'm going to get rid of this 5 here, because if I get rid of 5 on the left side, I almost have to get rid of it on the right side. And what's remaining? X is equal to 2. Therefore, my answer is x is equal to 2, and x is equal to 2 right here, and it all checks out.